Let's focus up on the board, please. I'm going to go over questions that are going to be very specific to the test. And I don't think I included anything from lesson 90 actually, even though I said I was going to. I don't think I did. But we do have two questions from lesson 88, however. So, lesson 88, um, make sure that you are able to graph numbers on a number line. Yeah, that's actually from lesson 86, so don't worry about that. Lesson 89, it's actually converting using unit multipliers. So if we have a problem like 15 yards squared, and we want to convert that to square feet, and they want us to use two or more unit multipliers, that means we have to go with, we start with 15 yards. To break up the square, right, we just separate it into yards and yards. That gives us square yards, gives us 2. And then we're trying to convert that, we're trying to get to square feet. So remember, we have to have yards in the denominator so they will cancel out the yards that are up here in this numerator. And we ask ourselves, do we have a relationship between yards and the feet that we're trying to get to? And we know that there is a relationship that we're aware of. And that relationship is that 1 yard has 3 feet. And that's true for both of these, of course. And then ultimately, we find out that this yard can cancel out that yard, and this yard will cancel out this one. So our yards are canceled out. We're left with feet, and actually we have 2 units of feet, so it's actually going to be feet squared. And then we just do our math. 15 times 3 times 3, and that's 135. So our answer is 135 feet squared. Times 3 times 3. Times 3 times 3 right there. Yeah, that was practice set. Okay, so that we'll have a problem like that. You have a problem with the number line. Well, you have to be able to you have to know, make sure you know counting numbers, whole numbers, integers, and rational numbers, what the differences are. You want to be able to do that. You're going to have to be able to do a problem that would be similar to this one. Minus 3m, and then minus 2mn, and then m squared n. And we want to multiply. We remember in our constants, we multiply our constants. We add our variables. Okay, so we multiply this negative unit by this negative unit, and the constants being 3 and 2. So negative 3 times negative 2 is what? It's a positive 6. And a positive 6 times with nothing over here, or 1, right, is going to be positive 6. So basically, since there's no other constants besides the 3 and the 2, we multiply them. 2 negatives equal a positive when we're multiplying, so that's going to be a positive 6. Now I just collect my variables, and I want to see how many m's do I have. Well, there's 1 there. There's another one that gives me 2, and here's 2, so that gives me how many? That gives me m4, and then I want to collect my n's. I have how many? There's 1, there's 2. So there's my answer, 6m4 and 2. Okay? Any questions about that, Tanisha? Yeah, positive times a negative is a negative. Sure is. That's right. Exactly right. Okay. Okay, it takes care of 87. Then on lesson 86. Oh, wait, we didn't do 86. Did we do 86? Yeah, we did. How come I don't have a... Well, if we have a problem from 86, I didn't highlight it, so I don't know what it's going to be. It's going to have to do with graphing. Yeah, it'll have to do with graphing integers, whole numbers, counting numbers, that kind of a thing. So make sure you look over lesson 6. I'm going to put it up here. Look over lesson 86. Okay. Now that takes us to lesson 85. 85 gives us our favorite kind of things in the whole world. It's going to be something like this. -2. Brackets. -3. -4. -5. Okay, that's what we're trying to do. So we have to do the stuff in the brackets first, right? Alright, so we got the, we're going to kind of do this shorthand here a little bit. All this is going to stay the same. This is going to change from, we have a -4 times a -5, or the opposite of 4 times the opposite of 5. And what's that going to be? +20, right? So I can get rid of all this stuff here, and then I can make this, I can put a 20 inside of here with the brackets there. So now I have all this. So basically all this is now gone. I multiplied it, I can't. They were two numbers side by side, I can't add them, I had to multiply them. So now I'm left with this part of the problem. And I got to do stuff that's inside the brackets here, right? So inside the bracket I have the opposite of 3 plus the opposite of 20. And what's the opposite of 3 plus the opposite of 20? What is it? Yeah, -23. Alright, and so then I wind up with -2 in brackets, -23. And then what do I do now? I multiply. What's the opposite of 2 times the opposite of 23? +46. That is the answer. Okay, what if we had one like this? -2 plus 3, -4, minus 5, -2. What do I do here? Parentheses first, nothing to do. Multiplication, right? So this one here I'm going to do, I got to take 3 times the opposite of 4, which is what? Okay, so this is all going to change to a -12. Okay, so let me just bring this down so it's not confusing. And we have this one here. Well, we can do it one of two ways, however you want. You can bring the minus sign down and just take 5 times the opposite of 2, or you can say the opposite of 5 times the opposite of 2, however you want to do that. It's better, honestly, it's better if you do it like this. -2 plus -12, and then minus, and then 5 times the opposite of 2, which is going to give us a -10. You are, because negative times negative is a positive anyway. So you can bring this down as a minus, opposite of 5 times the opposite of 2, and it'll kind of save you a step. But this is what we have right here. So we wind up with -2 plus -12, and then a negative times a negative is a positive, so it ends up being +10. Okay? And here we have, what's the opposite of 2 plus the opposite of 12? Yeah, the opposite of 14, right? The opposite of 14 is -14. +10 equals what? Exactly, and that is our answer. Right? Okay, this will be on the blog. If you didn't quite follow along, I mean, the purpose of this review is not to teach it to you. You should already know it. It's to refresh your memory, so we can't go through and reteach you how to do it because we have too many problems to go through. It's on the blog tonight. Go back and watch it a couple times, and hopefully it'll make sense. And if you have to do one or two of your own, do that too. But that's how we do those problems, and you will see one of those on the test. All right, you're going to see two problems like this on the test. You're going to see something that's going to say 3 plus x squared plus x minus 5 plus 2x squared. Okay, remember when we're adding these, we can't join unlike terms, can we? When we're multiplying, we can, right? But when we're adding, when we see these addition signs, a big warning flag should go up, and we don't start multiplying. We don't start multiplying the cons like 3 times 5 is 15 times 2 is 20. I have 3x's, 4x's. We don't do that. When we're adding and subtracting, we have to collect like terms. Okay, so the like terms here are a bit different, obviously. And remember, when we're writing these out, you always want to start with the numbers, the constants that have variables to the highest power first. So we're looking for things that are going to be x to the second, because this is the largest number here. So, and also, I might want to, so there's no confusion, I might want to put a 1 here, because x squared is the same thing as 1x squared. So I say I have a 2x squared here, and I have a 1x squared. I can add that together and get a what? 3x squared. Okay, so I've taken this one out of the picture. I've taken this one out of the picture. It only leaves me a couple things left. It leaves me this one here, right? Leaves me the x, and what's next to it? Positive sign, so I'll bring that down. Plus x, I got rid of that. Now all I have left is a 3 plus a negative 5, which is going to give me a what? 3 plus a negative 5. A negative 2, so it's going to be minus 2. And that, in fact, is my answer, 3x squared plus x minus 2. I've taken care of all my math. The who? I did. Right here, 3, and I took 3. Oh no, this 2x. This is 2x squared. This goes with the 1x squared. I can't add 5 to 2x squared. It's not a like term. Remember? You can only add like terms. I can't add a constant to a constant with a variable. No, I can't add that. They have to be like. They have to be all constants. The variables have to be identical. Remember? Okay, if you're not sure about that, if it's a little unclear, this is lesson 84. Write that down and review it. Okay, we don't collect unlike terms when we're adding, only when we're multiplying. These here, we're collecting the like term. Don't let that confuse you tomorrow. You're going to have 2 problems like this, 10 points. It's a letter grade. You miss both of these, you're going to drop a letter grade automatically. You don't want to do that. All right, you're going to have, you're going to love these. You're going to have 2 problems like this tomorrow. This is coming obviously out of lesson 83. Lesson 83. And the problems look like this. 5 times 10 to the 5th and 3 times 10 to the 7th. Okay, so we're looking for an answer here, and we know that we obviously want to take these constants, right, the 5 and the 3, and what do we do with them? We multiply and we get 15. Okay, and it's asking us to put them in scientific notation, so we have to have a number times 10 to a power. And what's the power going to be here? When we're multiplying, what do we do with the powers? We add them. So it's 10 to the 12th. Now, the problem is we have 15. Is that scientific notation format? No. Right now, the decimal point is right here, right? Where's it supposed to be? Right here. Okay? So here's where everybody gets confused. This is the point of tons of confusion, right? How do we know if this is supposed to be 10 to the 11th or 10 to the 13th? How do we figure that out? Amanda? Right, you could take this out. This is 15 times 10 to the 12th. You could take it out 12 places and then count back till you get to the right spot. But you can do that in your head. Just think, okay, if I go 12 places out here, but I'm one place to the right too far, I have to add one more place, I'm going to be at 13. Does that make sense? If you know you're right here, and you have to be right here. All you have to do is just add one more number to this, right? So that would be your answer. It'd be 1.5 times 10 to the 13th instead of to the 12th or to the 11th, because you're having to make that number bigger, so you're going in this direction. Say the decimal was here, the decimal needs to be over here, so when you get it there, now you're 12 places away, but you're also one more place away because you want one place in the opposite direction. So now you're going 13 places instead of 12. That's one way you can do it. Or you can do it the other way. You can say I had 15, now I'm going to make it 1.5 times 10 to the first because I was here, right? And I moved it over here. So to get it back to its original spot, I'm going one place to the positive. So I have 1.5 times 10 to the first, and I'm going to add to that what my 1.5 times 10 to the 12th. And I have like my original problem. I have 12 and 1 is 13. You can do it that way. So you can have two problems like that. So review it, watch the blog tonight or over the weekend. I mean, you have all weekend, maybe a couple of times. I don't know. All right. Somebody tell me by raising your hand what the area of a circle is. What's the formula, Liz? Right. So watch what I'm doing. First thing I do tomorrow after I put my name on the test is I'm going to get it on the top of my test somewhere. I'm going to write this down so I don't forget. Area of a circle equals pi r squared. The next thing I should write down, I don't know if you need to know it or not, but it'd be good to know this just in case. Area of a triangle is what? By 2, yep. And what is the formula for volume? Length times width times height. What is the area of a rectangle? 1 times width. Area of a circle we got. Triangle, volume. Huh? I don't think we need circumference. I don't think we need circumference. Okay, what about perimeter of anything, of a rectangle, we'll say? Yeah. Yep. Yep, it's length. You can do it a couple ways. Length plus width plus length plus width, or length times 2 plus width times 2, right? 2L times plus 2W. However you want to do that. Okay, some of the formulas you probably should know. I don't know if we have to know all of them. We'll find out here in a minute, but I know you want to know the area of a circle. I want to know what pi is, of course. All right, and then you're going to have to do some ratio boxes. So make sure you're familiar with the ratio boxes. Let's see if we can figure this one out. 20%, here's our problem. 20% of the 4,000 acres are plowed. How many acres were not? Can we do a ratio box with that? Let's see. Our book is not showing a ratio box for the answer, but I'm curious to see if we can do a ratio box for it. If we did a ratio box, yeah, how many acres are not plowed? This is what goes in here. What does our percent go? Now, this is a percent problem, right? Does it go in the first column or in the middle or over here?
The last column. Wait, I'm sorry, it's middle.
Middle? Let's say we put it here,
Oh, I got it this time, and I'm the stupid kid.
and I'm a stupid kid. You're not a stupid kid. What do you think, Brooke? What do you think, Brooke? What do you think? You said you got it. What do you think? You said it goes in the middle? Okay. So what's going to go on the bottom here? 100? Okay, then we have 4,000 total acres. Where's that going to go? Where's that? Oh, right here. Actually, our total goes over here. This is our total here. This is our actual count. So where's our 4,000 going to go?
Wait, no, sorry, last one.
Here?
Yes.
4,000? Okay. And we said 20% of the 4,000 acres
That goes on top. That goes on top. Planted.
here?
Yes.
Okay, this is going to be plowed? Not plowed? Okay, so 80% right here. Okay. We're trying to find out how many are not plowed, right? So we're going to have 80 over 100 equals x over 4,000. Now we can reduce left to right here, can't we? Okay, this is going to be, so what are we going to reduce this down to? 1? This will be 1, and this is going to be what? 40? Okay, so now we're left with 1 times x is x. 80 times 40 is what?
320.
No, you got 2 zeros. 32 plus 2 zeros. So we're saying this is 3,200, and then this must be 800. And guess what? You're absolutely right. Yep. Yep. Yeah, you could say if you wanted to 20% times 4,000, right? You can figure out what that is. And then of course now we can't take 20%, so what do you have to do? You can put 20 over 100 to get rid of the percentage sign, can't you? So we can get rid of this and say 20 over 100, then we can reduce that to what? To 1/5, right? To 1/5 times 4,000 over 1. It would be 800. And that's telling us that 800 is plowed, right? So then we would just subtract that from the 4,000 and get our 3,200 that way. So that is another way to do it. That's probably the way the book would show you to do it. They wouldn't even use the ratio box. I think the ratio box is nice, but whatever works for you, Brooke. The bathroom? That works for you. Go ahead. All right. Okay, we got to hurry. Spent a lot of time with that question, but I think that's an important one. So you're going to have a couple of questions like that, 2 questions from that like that. Okay, I'm going to pause. I'm going to stop this one right here.